Alright, so this problem is you go hiking, you fitness person you, and you go 25 kilometers in a direction 60 degrees above the horizon, and then you travel 15 kilometers in a direction 135 degrees. What is, not above the horizon, just 60 degree, and then you travel 15 kilometers in a direction of 35 degrees. So what's your resultant displacement? Okay, well, you need an axis system. So we create our axis system. And at first you travel 60 degree. So that means we need our value to be 60 degree. And we'll call that value A, and we'll say that A equals 25.0 kilometers, and that was at 60 degrees. And then we traveled 15 kilometers in a direction of 135 degree. So by convention, our 135 degree would be from this point. Remember, we're going tip to tail. So 135 degree would have you traveling, we'll say about here. Alright, and there's your 135 degrees there. And we'll call that B, and we'll say that B equals 15.0 kilometers. So if we're going to add these two up, we would have a resultant vector. Said resultant vector would be this guy right here. But we're going to be adding them together by components, so we are going to separate the A vector into the B vector. We're going to keep our axis system just as we've drawn it. So our A vector, if that's 60 degree on our axis, then this would have to, by definition, be 30 degrees. So if we were going to break it down into its x and y components, AX would be right here. And we would say that that's a positive AX value since it's on the positive x-axis. And AY would be this fun fellow right here. And we would also say that AY is positive on that axis system. Then we could take care of our B vector. Alright, and our B vector was 135 degree if we look here. Alright, so imagine we are going to do our angle by convention from the positive x-axis, which means that our angle would be this portion. Alright, so it'd be, if this is 90 degrees of the 135 degrees, then what we have left is 45 degrees. Alright, because 45 and 90 would give us our 135 degree. Alright, and that's our B vector. So now when we do our components, we will say that this is our BX component, and this is our BY component, and you're going to notice that our BX component should be just like that. Alright, so we have, from the angles that were given in the problem, we have switched them so that they are the angles in reference to the positive x-axis as our convention deems necessary. Alright, and that would be 35 degrees on the positive axis here and 45 degrees below the positive axis here. So now that we have those values, we can break each vector down into its component. Alright, so we could say that for the A vector, the x component is going to equal the A vector times the cosine of the angle created with the positive x-axis. For the B x component, that's going to be the b vector times the cosine of the angle that was made with the positive x-axis. For the y component, we're going to say that that's the a vector times the sine of the angle made with the positive axis. And for the b vector's y component, it's going to be b vector times the sine of the angle made with the positive x-axis. So we can now plug in these values. When we do this vector addition, we can only add together x's to x's and y's to y's because they're not in the same direction. So that means that we will have to find the resultant x value vectors and the resultant y value vectors and use Pythagorean's theorem in order to find the total resultant vector that we want to solve for. So in the x direction, that's going to be a cosine theta plus a sine theta. In the y direction, it's going to be, it's going to be a cosine theta and b cosine theta. And in the y direction, it's going to be a sine theta plus b sine theta. So we can now solve these plugging in their values. For a, it's going to be 25.0 kilometers times the cosine of 30 degrees, and we're going to add that to 15 kilometers times the cosine of 45 degrees. Now we need to be very specific. Both of these are in the positive direction for our x-axis, so we are in fact adding them together. For our y values, we're going to have 25 kilometers times the sine of 30 degrees. And now here we know that that 45 degree was below the y-axis, so we're actually going to be subtracting or doing a negative 15 kilometers times the cosine, or times the sine, of 45 degrees. And then you're just going to plug in your variables here, which we need to do on a separate sheet of paper. Alright, and we're going to get that the x values added together are going to be cosine of 30 times 25 plus the cosine of 45 times 15, and that should give us a total of 32.3 kilometers. In the y direction, we have 30 sine times 25 plus 45 sine times 15 negative 1.8 kilometer or 1.9 kilometers. And so these are the x and the y components of our vector. Our vector is actually a displacement vector, so you could use d for displacement to represent it. But now we know that the resultant vector in the x direction had 32.3 kilometers, and the resultant vector in the y direction was 1.9 kilometers. So our resultant vector is going to be the Pythagorean theorem of 32.3 squared plus 1.9 squared. And take the square root of that, and you have a resultant vector that is 32.4 kilometers displacement from your origin. And then we need to know the angle because this is a vector quantity, so it's only fully described by a number with units and a direction. Our direction is going to be given by an overall angle, which is going to be equal to the inverse tangent of the ratio Rx over Ry, Ry over Rx, opposite over adjacent, which is going to be 1.9 over 32.3. And that should give us an angle of 3.37 degrees. So our full answer for this problem is going to be 32.4 kilometers at 3.37 degrees.